Hello everyone. In this video, I'm going to present my final year project AutoAnalyst-AI, which is an autonomous data intelligence system. Today, data analysis requires technical knowledge, manual pre-processing, and also model selection and domain understanding, which creates the huge gap between the raw data and real insights. So my question was simple, like why can't a system understand a data set the way a human analyst does? So this autoanalyst AI tries to solve this by combining the features like automated data profiling, intelligent pre-processing, and machine learning strategy recommendation, explainability, along with data-aware AI chat using RAG, all in one pipeline. Our problem statement defines in real world project, data sets are usually messy and the target column is unknown for large data sets. And pre-processing decisions are manual and models are chosen blindly. So almost most tools like Power BI or Excel only show like what happened but not what should be done or the explainability of the problem. So we have a system that understands the dataset structurally, statistically, and semantically before applying any machine learning models. Our project objective is automatically analyze the dataset structure and detect the data quality issues and recommend pre-processing steps and suggest ML models based on the data type and also explains the feature importance and provide a domain aware reasoning using RAG, which supports both structured and unstructured data sets. And this makes useful for students, data analysts, and also non-technical users who are usually performing any ML model before knowing the data set. About the system architecture, the system works in stages. The first stage would be the data ingestion, followed by we have data profiling and also our decision engine and pre-processing pipeline with the model strategy generator and explainability engine along with the domain aware RAG knowledge. So what are the pre-processing steps we are performing on the data sets? It are stored in the knowledge base of the RAG, which is then enables the user to communicate easily to know what the data set is about. So the module one, we have data ingestion part where the system accepts the CSV, Excel, text, and also PDF. Followed by that, we have our module 2 data profiling. Like after loading the data set is profiled automatically, which detects for the number of rows, column, whether it is a numeric type or categorical values, and also for the date and time. And most importantly, it automatically detects the target column using the column name, cardinality, and the uniqueness ratio, and along with the data type, like which mimics the human reasoning. Like, how could I pick a target variable? So the system behaves like a junior data analyst. Then we have our module 3 data decision engine, which is an intelligent start. Like based on the missing values and the outliers we get in the data profiling part, this decision engine decides whether the problem is a classification or a regression type and also suggests pre-processing steps and flags the risky columns and warns about the data leakage. Like for example, let's say if many missing values exist, it recommends the advanced imputations like mean, median, mode, and also helps in bfill and ffill modules. And it extremely outlier exists, it suggests like capping or transformation. And more number of missing values in that particular column, it enables also for the dropping of that column, which makes no sense for predicting the target. And module 4, we have our EDA. where missing value is handled, and scaling, encoding, and also feature extraction and balancing of the data set takes place. We also have text pre-processing, like each step is recorded as a pipeline. So here the system tracks what changed and color modified cells and allows the undo and exports like clean data. Then we have our module 5, model intelligence. Like instead of training blindly, the system inspects like what's the data set size and also the features we have, whether it is categorical or numerical, and the target type. Then recommends the suitable algorithm, machine learning algorithms, when to use and what are the key parameters we are using, and the values we need to set for that key parameters. Example, let's say if it is in a small data set, it can recommend for logistic regression, and for large data sets, it can go for random forest where the model performs really good. And for high dimensional data sets, can go for XGBoost. Like this prevents like overfitting by default and blind auto ML. And also for a newcomer, it tells like what are the key parameters we have and what all values we can set up to its threshold. And followed by that, we have our explainability engine, where it analyzes the correlation and mutual information variance and the redundancy, where it produces the feature importance scores and the redundant feature and stability metrics. Followed by that, finally we have our RAG engine, where like instead of charting with a generic LLM, the system builds dataset specific knowledge, where it stores the profile info, the EDA patterns, correlations, outliers, and the target info. So then uses the vector search to answer those questions like what is the data set is about and the business value can be extracted. So this AI doesn't hallucinate, it reasons from your data set only. This turns my data set into a knowledge base. And let's see the implementation of a project. So the data set I have used is bank train, which contains age, job, marital status, education, and balance, housing loan. And these are about the data set. And in data set profiling part, first, it gives the dataset overview, which have how many rows, columns, and duplicate rows, and the target. Here, the target it predicts as the outcome, and the missing value. In balance and outcome, we have missing values like it depicts through the graph, and the column type, whether it is categorical or numerical or date and time. And we have the numeric summary, which calculates the mean, standard deviation, minimum, maximum, and the skew values for that data set. And for the categorical features, we have plotted the graph for each and every feature in the data set, where the count and the job. Through this, the data analyst will be able to easily analyze about the data set. So for each and every feature, we just plot the graph for the distribution and the count. Followed by that, we have outliers, like where all the outliers are present. And in decision engine, like we should select for the target column. It tells the problem type. It is a classification task detected, and also these are the recommended pre-processing steps. Like it says, simple imputation for the balance and for the outcome column is needed, like either through mean or mode. And Cap or remove the outliers like where all we have in age, balance, duration, campaign, and previous. So here we can perform for the dataset pre-processing steps. For here we can download for the pre-processed data set. And for model training, we here choose for the target column, and it tells it is a classification problem, and for classification it recommended those models with the parameters and what are the values we can set. Like for logistic regression it says like baseline or interpretable classifier, binary classification problems, and works well with linearly separable data. And for the suggested range on the parameter, we have like class weight and the maximum iteration we can perform, and the penalty like L1, L2, and elastic net, and followed by the explainability. Same here, we should choose from the target value, and it tells like which are the features are very important to that for training that model. Let's say here the balance decreases the target and has influence strength of 36.05 percentage, like for all the features we have. And here we can inspect for the feature like for days which decreases the target and has influence strength of 66.71 percentage, and the direction and the stability. In drag knowledge, we can build the knowledge base for that data.